This is Dr. Lennon, and we are going to be going over the Test 2 review problems. So let's get started. The first one is a word problem here. So basically we've got a 260 meter wire cut into 3 pieces. So it looks like the variable that makes the most sense is let's let x be the length of the first piece. And then from there, they tell us that the second piece is 4 times as long as the first. So 4x is going to be the length of the second. And then the third piece is twice as long as the second. So that's going to be double 4x. So that is going to be the length of the third. So if you add those all together, you get the length of the whole thing. So x plus 4x plus 8x equals the total length of 260 meters. So those add up to 13x. And dividing by 13, we see that our lengths, so this comes out to x equals 20. So our lengths here, if we're doing each piece, we get 20 meters for the first piece, 80 meters for the second piece, and 160 meters for the third piece. And that is all you have to do for that one. So problem number 2 is another word problem. We've got $2,600 for fuel expenses for the year. And we want to know how many miles we can drive if gas is $3.25 a gallon and we average 28 miles per gallon. So let's go ahead and figure that out. So if we take the $2,600 and divide by the $3.25, that gives us the total number of gallons that we can buy. So 2,600 over 3.25. So that's dollars over dollars per gallon. So the answer is going to be in gallons if you just focus on the units. So 2,600 over 325 comes out to 800 gallons. So then if you take 800 gallons and you multiply by the fuel efficiency of 28 miles per gallon, the gallons cancel and they give us our answer in total miles. So 800 times 28 is 22,400 miles. So that would be your answer for this one. So that's a pretty high number. I think, I don't know if you look it up, I think most people average somewhere around 10 to 15,000 miles a year, so it seems like a decent allowance. At least the answer sounds reasonable. Okay, so let's go ahead and continue with problem number 3 that I believe is a systems of equations problem. So for number 3, we want to solve the system of equations. The easiest way to do that is by eliminating a variable. So here it seems pretty reasonable to eliminate y. So if we keep the top equation the same and multiply the bottom equation by 2, we'll end up with the same equation on top, 5x plus 6y equals 8. And then on bottom we will have 2x minus 6y equals minus 22. That way when you add the two equations, the y's drop out, so we end up with 7y equals negative 14. And then we can divide by 7. So we get our y value, so y is negative 2. Remember that the solutions to these problems are ordered pairs. Typically it's going to represent a point where 2 lines are crossing, so we need to solve for an ordered pair, an x and a y. So basically we can plug that in to the bottom equation. So x minus 3 times negative 2 should equal negative 11. So x plus 6 equals minus 11. And then we can subtract 6, so we see that x should be negative 17. So your solution set, so I'm just checking that if we go back, if we plug both values in, negative 17 plus 6, yeah, that works. So the solution is negative 17, comma, negative 2. So notice that's an ordered pair, an x value and a y value. So number 3 is pretty straightforward. Number 4 is another system of equations, but it's going to be a little bit more difficult because we're going to have to multiply both equations by a number if my memory is serving me right. Okay, so for number 4 here, we need to pick a variable to eliminate. Either one seems reasonable. I'm going to do it so that my numbers stay the smallest. So I'm going to try to eliminate y. So I'm going to multiply the top equation by 3, so I end up with a 6y there, and the bottom equation by a negative 2. That way I end up with a negative 6y. That way when I add the equations, the y's will cancel. So I end up with 21x plus 6y. That equals 72. And on bottom, I have minus 10x minus 9y. Minus 6y. Looking at the wrong spot there. So we get minus 6y equals minus 50. So then I can add the equations together, and I end up with 11x. The y's cancel. 72 minus 50 is 22. So when I divide by 11, I get my x value. So x is just equal to 2. And then same as in the previous equation, we want to plug that in to solve for y. So I'm going to plug it right back into the original top equation. 7 times x, which we know is 2, plus 2 times y has to equal 24. So we have 14 plus 2y equals 24. And then what we want to do is subtract 14 and divide by 2. So we subtract 14, and we get 2y equals 10. We divide by 2, and we get our other value, 5. So here the solution is the ordered pair 2, 5. And again, you can check that in the question by plugging them both back in. Like in the top equation, 14 plus 10 equals 24, and in the bottom, 10 plus 15 equals 25. So the solution checks out. So let's move on to number 5 that deals with solving a quadratic equation. For this problem, we're solving x squared minus 169 equals 0. We could use the quadratic equation, but it's easier just to use the square root property, so we can add 169 to both sides. So we end up with x squared equals 169. And the square root property says if you have x squared equal to a positive number, we know x is just equal to plus or minus the square root of 169. And you can check in your calculator, but the square root of 169 is 13. So you have two answers here, just x is equal to plus or minus 13. And that's your answer. So number 6 is another quadratic formula problem, but we're going to be using the quadratic formula. So maybe I can write that down just on the side here, the square root property. So this says if k is positive, then actually if k is greater than or equal to 0, then x squared equal to k has solutions x equals plus or minus the square root of k. And that's all. Okay, so let's continue with the next one. Okay, so for this one we want to go ahead, so this is x squared. We want to go ahead and apply the quadratic formula. So let's remember what the quadratic formula says. The quadratic formula says the solutions to ax squared plus bx plus c equals 0 are x equals minus b plus or minus the square root of b squared minus 4ac, with everyone being divided by 2a. So we're applying that formula for this problem, and here we just have a is equal to 1, b is equal to 17, and c is equal to minus 20. So we can go ahead and just plug that in and simplify. So x will be negative 17 plus or minus the square root of 17 squared minus 4 times a times c. with everyone being divided by 2 times a. So let's go ahead and perform the simplification. So minus 17 plus or minus the square root of, that looks like 289 plus 80, so 369 over 2. And then you can plug both of those into your calculator if you want to get 2 approximate answers. So I'll put a little squiggly because that means I'm just approximating the decimal point. So let's see, we get minus 17, we'll do the smaller one first, minus the square root of 369 divided by 2, and approximate, that's about negative 18.10. If I round to 2 spots, again, it's going to depend on whatever the problem asks you for in terms of rounding accuracy, or if we look at the same thing but now make it positive, we end up with 1.10. So, or x is 1.10. So, I mean, pretty much that's it. You just need to make sure that you're not messing around with any of your negatives or anything like that, but you just go ahead and plug everything in, reduce with your arithmetic, and then use your calculator to approximate if need be. So let's look at the last 4 problems. The last 2 are plane geometry, and then the final 2 are solid figures. Okay, so for number 7, we want to find the perimeter and area. The perimeter is straightforward. So we have a trapezoid here. The perimeter is just the area around the or the length around the outside. So we just add together all the sides. So we have 20 plus 20 plus 5 plus 25. So our perimeter all the way around is just 70 meters. The area is a bit different. So the area formula we want to remember for a trapezoid is base 1 plus base 2 over 2 times the height. So in this problem, it's kind of tipped over. So our bases are the 5 and the 20 that are parallel, and the height is the 20 that connects the length 20 side with the length 5 side. So our area formula here, applying those things, we get 5 plus 20 over 2 times the height of 20. And so that comes out to, let's see, 250 meters squared. So that's the answer for that one. So just applying the 2 formulas. Perimeter, there's not really a formula. You just add around the sides if you know them all. The area formula for a trapezoid, that was fairly specific, so you want to look that one up. Okay, so for this one, we want to find the area, but we don't know the height. So the area formula for the triangle, let's recall, is just 1/2 times base times height. So we want to find the height, which is the question mark side in the triangle here. So since it's a right triangle, meaning it has a 90-degree angle, we want to use the Pythagorean theorem to find the height. So we can say h squared plus 15 squared has to equal 28 squared, because a squared plus b squared equals c squared, where c squared is the hypotenuse. I'm just calling it h because it happens to be the height in this problem. So h squared plus 225 equals, what is that? So 28 squared comes out to 784. And then we want to subtract 225 on both sides. So we end up with h squared equals, what is that? So we need to carry, so we end up with a 9, 7, 5, 559, is that right? Let me put that in the old calculator. Yeah, 559. So I'm just a little bit surprised since it doesn't appear to have come out very nicely. So h is just going to be the square root of 559, and that is approximately about 23.64. So if we want to apply the area formula up here, our area is going to be 1/2 times the base value of 15 times the square root of 559, which is the height that we just found, and we can approximate that now. So we end up with about 177.32, and that symbol, so notice there's kind of like 2 apostrophes or a quote, so that means that it's being measured in inches, so this answer is going to be in inches squared. So I'm going to write IN squared. Okay, so the last 2 questions that we're going to look at involve area and lateral surface area of a cylinder and a cone. So we'll go ahead and do those 2. So we want to find the lateral surface area and the volume of the cylinder. So we have 2 different formulas here. So the things that are given is we know that our radius of this cylinder is 40.5 and the height of the cylinder is 86.8. So the surface area formula is basically the height times the circumference of your circle. So the lateral surface area here is given by the formula, let's see, 2 pi RH. So our lateral surface area for this problem is going to be 2 times pi times our radius 40.5 times our height of 86.8, and we'll get an approximation there, and that's going to be centimeters squared. So 2 pi times the 40.5 times the 86.8. So this comes out to a pretty large number. So 22,087.91, and as mentioned, that is centimeters squared are the units. Let's remember the volume for the cylinder. So the volume is going to be pi r squared h, because it's just the circle at the bottom multiplied by how tall the figure is. So the volume for our particular numbers are pi times 40.5 squared times that height of 86.8. So again, we can get an approximation for that. So that comes out to, let's see, 447,280.17. And that is going to be centimeters cubed for this example. All right, so moving on to the last one, we are going to do the same thing with a cone. So the cone has another formula that's slightly different. So this is kind of split up into the 2 parts. We have this part, and we also have this part. All right. Okay, so for this one, we want to find the lateral surface area and the volume of the cone. So what's given here? We're given that the height is 16.2, and we're also given the diameter is 12.1. So that means the radius is half of that. So the radius would be 6.05. So the formulas are typically always based on the radius, so it's a little bit easier to go ahead and solve for the radius before you start doing anything. So let's go ahead and do the volume first here, because the volume is going to be a little bit simpler formula based on what we're given. So the volume of a cone is given by 1/3, basically the same area formula as the cylinder, but you have the 1/3 in front. So 1/3 pi r squared h. So we have 1/3 pi, our r value is 6.05, and our h is 16.2. So this comes out to, let's see, 1/3 times pi times 6.05 squared times 16.2 comes out to about 620.95. Again, this is going to be units cubed, so 620.95 and centimeters cubed. I'm just a little bit curious. Did I get the volume units on the previous one correct? Yeah, I did. Okay, the lateral surface area. So the lateral surface area formula for a cone is actually not so hard. It's just pi times r times L, where L is the slant height. So we don't know the slant height, but if you think about the cone, looking at it dead on, you actually have a right triangle where we have the slant height here, L, we have the regular height 16.2, and then we have the radius at the bottom 6.05. So we can use the Pythagorean theorem to find that. So we know 16.2 squared plus 6.05 squared is going to equal our slant height squared. So L squared is going to be equal to something like 299.0425. So L is going to be the square root of that number, which comes out to 17.29, let's say. So now we can do our lateral surface area. Our lateral surface area is just going to be pi times the radius 6.05 times the slant height that we just found, which is about 17.29. And the lateral surface area is going to be units squared. So let's do pi times 6.05 times that slant height, and that comes out to about 328.68. And that's going to be centimeters squared because it is a surface area. So again, we have those two things kind of separated here. All right, so that's it for the test review. Please let me know if you have any questions. This is Dr. Lennon signing off.